Hello, welcome to our CS348 final demo presentation. My name is James, and also with us today, we have Brad.
Hello.
Jeffer.
Hi.
And Robbie.
Hey.
Today, we want to talk to you about how it's currently unfathomably difficult for students at the University of Waterloo to plan out their degrees and determine the courses that they still need to graduate. And actually, this process has so much friction because information about degree requirements and courses is just scattered around different areas of the internet. The application that we built removes this friction and enables students to effortlessly find all the information they need for their degree planning.
So our first feature, students can provide their desired degree and the list of courses they have taken, and the app will generate a list of courses that they need to complete their degree. They're shown a list of prerequisite groups where each will display a list of courses and the amount of these courses needed. So let's say you say you already taken CS241. So let's add that in. You can see that this course will now disappear. The backend query for this feature allows us to get course codes and groups from the natural join between the course group member table as well as the degree requirement table. And then this gives us a map of courses to its group ID as well as other metadata information. So this brings us on to our next feature. By clicking on a prerequisite, we can see that there is a pop-up with a flowchart of all the prerequisites for that course, so CS444. All the ones that will be taken will be in green. The ones that can be taken next will be in blue. So for example, I'm in software engineering. And so based on this prerequisite graph, there's a really obvious OR between the CS350 option and the SE350 option. I know that I just need to take one of them. This is our fancy feature number 1.
To generate this prerequisite graph, we wrote a complex recursive SQL query. Here's how the query works. So our base case of the recursive query just selects the course we want the graph for. Then our recursive step joins the prerequisite table in our database onto this recursive query and selects each course's prerequisites. And this repeatedly happens until we run out of prerequisites. So then we get a table where there's each course and its parent. And then there's one course without a parent, which is just the root of our tree. Next, we have to convert this table into a graph. And this is done using many recursive Python functions. And finally, once we have this graph into a data structure, it's sent using JSON to our front end and displayed. This is one of our fancy features as well.
Students can provide a desired course, so we can write CS348, and the app will return the general description of the course title, and course types. In addition, a list of prerequisites that need to be taken before enrolling in the course, and the prerequisite graph can be shown as well. The SQL query for course general information is a select query from the course table. And the prerequisites are obtained by finding all the courses in course group member table by using the course group ID in the prerequisite table. Students can see the historical data of a given course, and the term tab displays the current term information and the next term information. A table for the historical availability of the course is shown as well. Each row represents a year, and there are 3 columns: winter, summer, and fall. In each box, we display the number of sections and the professors that are teaching them. And based on how full the capacity is, we use the color red, yellow, or green to show the enrollment numbers. As for the SQL query, the current term and next term course information data is obtained by selecting information in course offering table based on the current and next term's code. To calculate historical course data, we use 3 separate transactions to generate and join multiple temporary tables. We use advanced Postgres SQL features such as cases, array aggregation, and group by's. All 4 transactions are part of this feature, and this is one of our fancy features.
In the Prof Info tab, we show a list of all of the professors that have taught this course and order them by the total number of times they teach this course. We are using a group by query on the course offering table by the professor's first and last name and filter by the course code. We then count the aggregating information to get the number of terms and sections they have taught using the Postgres array ag function. In addition to searching for courses to see who's teaching them, users can also search for specific professors and see what courses they have been teaching. We can search for professors by a partial match in the first name and last name, and the list of professors that match this name will be returned. When we click on a professor's name, a pop-up will show to display the Rate My Prof ratings of this professor, should they have one, and the courses that they have been teaching, and during what year and what term the professor taught these courses. This is one of our fancy features that includes complex setups, including views and indexes. We'll create the following view to join the course offering table with the Rate My Prof record table. We then use a complex pattern matching index on the prof names for text search. When we click on the name of the prof, we use a different endpoints, and the following query gathers what courses they have been teaching, again, with the group by and an array ag function.
So for our final feature, say a new course is created at Waterloo. The Add New Course feature allows professors and admins to add new courses. They can specify the course and its metadata, as well as prerequisites here. When a student goes to search for their courses, they can see it come up here.
And Rob will also demonstrate now how the prerequisite graph is also once again dynamically generated on the fly.
For our backend query, we have 6 insert into statements. So this inserts into various tables and maintains foreign key constraints, as well as data integrity, as you can see here.
In terms of system support, this application uses Angular Web Framework for front end, Flask library in Python with REST endpoints for backend, and PostgreSQL database server. We use CyclePG2 to access the SQL database. The server and the database are hosted on GCP, and the front end is hosted on Netlify.
In terms of the contribution of each member, Brad worked on the infrastructure, backend, SQL scripts, data scraping for school info, course offering data, Rate My Prof, and UW Open API. Jeffer worked on the front end, backend, as well as SQL queries. James worked on course info scraping, ETL on UW Open API data, backend, and SQL. And Robbie worked on data scraping, front end, and backend for various features.
Overall, this was a great learning experience for us. We were able to apply new techniques we learned in this course while we were creating something useful for us and our fellow classmates, and we know we'll be using this in the future. It will let us plan out our degrees, quickly understand course prerequisite paths, and compare different course offerings in greater detail than we ever could before. This project was also extremely educational. So not only did we improve our existing skills in teamwork, SQL, web development, but we also got to develop new skills we learned in this course, CS348, such as normalizing data schemas, recursive SQL, and creating indexes and constraints to enforce data integrity. Overall, we learned a lot, and we hope you enjoyed watching this demo as much as we enjoyed making it.